I thought designing a body for 250 miles per hour would be straightforward. Make it smaller, make it smoother, right? But what I actually found is that losing drag can make it less stable. And at 250 miles per hour, unstable means one thing. So in this episode, I've been using CFD to try and answer one question: what shape actually works? And then turn that into a real body for my Project 250 machine. I've been running aerodynamics CFD simulations, which are like using a virtual wind tunnel, not to chase perfect numbers, but to answer the important questions. Will it flip? Where is the downforce, and how much drag is there? Because at these speeds you don't get a second chance. So I started by analysing the beast, and this design was rushed. So I thought, great, loads of easy wins. Yeah, that was optimistic. First step, baseline run. Then after that, start experimenting. Front downforce was already strong, so it was rear downforce and drag reduction that I aimed to target. I tried proper aerodynamic profiles on the body, the fin, the canards, and the result? More drag and less downforce. Great. It turns out making things more aerodynamic can actually make them worse. I'd been dumb. What change did what? The only way of really knowing was to only change one thing at a time. Which sounds simple, but if you're like me and constantly thinking of new ideas, it's painful. But it's the only way to actually learn what's going on. To get back on track and try and find some kind of improvement, I went back to the start and just added a supercar-inspired diffuser on the rear end. I found good results with less drag and more downforce. A small win. Next, I removed one of the fins. Drag dropped as expected, but fins aren't there for drag, they're there for stability, basically keeping the car in a straight line. And at 250 miles per hour, stability is everything. For the car to be stable, the aerodynamic forces need to act behind the centre of mass.
See how unstable it is? Now, if I shift the centre of pressure here and blow on it, you see it's much more stable. Just the centre of pressure is behind the centre of gravity.
Otherwise, the wind starts steering the car, which ends badly. So I simulated a crosswind, then worked out the position of the centre of pressure just as I'd done for the downforce balance with the straight line analysis. Twin fins, rock solid, centre of pressure 100mm behind the centre of mass. Single fin, 50mm in front of the centre of mass. Yeah, that's not going to end well. So it turns out that, even though it was rushed, I'd nailed the original beast design. With the diffuser adding a bit more rear downforce, that's the best that I thought I could do. So with those learnings, I moved back on to Project 250. I tested the new design. 20% less drag. Great. But almost no downforce. And I genuinely thought I'd broken the entire project. After a lot of head scratching, I realised I'd accidentally halved all my results. So yeah, that was user error. But downforce was still down, not surprising given the narrower body. After fixing it, tweaking the canards and sharpening up the rear end, the stability was good, but I'd only gained about 14% drag reduction. Maybe I could get some drag reduction by fitting smaller fins, but after designing an entirely new car, this was pretty disappointing. Then I got a comment from Dave's Entropy. Make it more like a teardrop and extend the rear. And I thought, alright, let's try something a bit ridiculous. So I added 100mm to the rear and went for a single fin, move right back and hit simulate. And when I saw the result, I genuinely didn't believe it. 28% drag reduction. This was massive. Equivalent to driving the beast with a 40 mile per hour tailwind. But almost no rear downforce, so not perfect. I tried extending the front by 50mm just to understand if that helped, and I found a small gain, but it would probably make stability worse, so I decided to go back on this one. Tweaking the rear end once again, found a bit more rear downforce with minimal drag. And this thing was stable, even with the single fin, thanks to where the fin is, basically further backwards. Now the shape was done, I thought I'd try something. Right, with the centre of gravity moved backwards, so this should be unstable. And it doesn't turn. There we go, instability. And then with the centre of gravity where it's supposed to be, stable, yes. A perfect demonstration, thanks to Burt Munro. I feel a bit lightheaded now. I got back into the CAD, making sure my chassis fits inside the body, splitting it up into 5 pieces for 3D printing, and adding lights and a service hatch. This was a lot of work. But what lights do I use? There's hundreds of options, so I tested the 4 most promising. It's got quite a big spread of light, so probably not ideal for speed running because you're a long way away. If it spreads the light, you're not going to be able to see it from as far away. Oh my god. Look, these are surprisingly powerful compared to those motorbike lights which run on 12 volts. I mean, that's actually pretty good, isn't it? Gets very hot though. There's a slight downside. Then this one is like a very focused spot. So I think that one could be quite good. With their small size, good light output and less heat, the mini 3-watt lights work best for me. And I'm adding side lights this time, because last year I completely lost sight of the car mid-turn. I can't see it, oh no. Eventually the design was complete, and it was time for loads of 3D printing. Because this body is a bit narrower than the Beast's, it fit on my Bamboo Lab A1, which gave fantastic results. Then I could assemble it to the carbon chassis to check fit up before going any further. And this is where I've got to now. It mostly fit as planned, with one small area I'd got wrong needing a reprint. Now, we're going to name this thing because Project 250 isn't going to cut it. Back in episode 1, you guys suggested some very good names. So I've picked my favourites and I'm putting them in the comments. Add a like to the name you think I should go for, or add your own suggestion. Go and vote, and next episode, this thing gets its name and a new colour scheme. I feel like we've learnt a lot today. Length matters more than anything. A longer car equals lower drag. I shouldn't be surprised, but for some reason I am. Extending the rear helps more than the front, and actually improves stability, so you need less fins, reducing drag even more. But with CFD, you must stay strong and change only one thing at a time. Otherwise, you've got no idea what worked. And honestly, I did this in the wrong order. I should have designed the aerodynamics first and then built the car around it, not the other way round. But overall, I think we're in a good place with the design of this thing. Next up, we complete the build and test it on the runway at Rossa round 1, because simulations are one thing, 250 miles per hour is another. Subscribe so you don't miss it, and I'll see you in the next one.